and today we are going to be covering area and perimeter. Our objectives or intent for today's session is to understand how to calculate perimeter in 2D shapes, including a combination of rectangles, understanding how to calculate perimeter and circumference in circles, understanding how to calculate area in 2D shapes, including a combination of rectangles, and how to calculate area of triangles and calculate area of circles. So the first topic that we are going to look at is perimeter and calculating the perimeter of rectangles and triangles. So perimeter is the total distance around the edge of a shape, and we calculate this by adding the amounts together. And a good way of remembering that perimeter is adding is think perimeter means plus. Plus, another word for add. The two p's together, perimeter plus. So we've got three shapes on the board. Our first one is a rectangle, and we know about rectangles that they've got two pairs of equal sides. So here and here are the same, and here are the same. So our perimeter is going to be 6, add 3, add another 6, add another 3, which is then 18 metres. Then we have what's called an isosceles triangle. And isosceles triangles have a pair of equal sides. So we then know that this side's going to be 3 metres. Add them together, 7 add 3 is then 13 metres. And then our last one is what we call a combined rectangle. But here, before we calculate the perimeter, we need to establish what our missing sides are here. So we've got a missing side here and a missing side here. Now, if we look, we know from the top to the very bottom is 7 metres, but from here to here is 2. So we know whatever we add to 2 metres must make 7, which is 5. And then the same here, we know here all the way across is 9, but from here to here is 4 metres. So whatever we add to 4 to make 9, which is another 5. Now we've got our missing lengths, we can now do the perimeter. So 7, add 4, add 5, add 5, add 2, add 9, gives us 32 metres. And that's how we calculate simple perimeter. But now say we've got problem questions where perimeter is used in daily life. So for example, because it's the outside of shape, things like fencing, skirting boards, hedging, anything to do around the outside of a shape. So say a question asks for fencing and how much it would cost to fence a specific area. So for example, James needs to fence his garden, which is 14 metres, and each panel is 2 metres wide and costs £12. How much will it cost altogether? So firstly, we would calculate the cost by following the steps, and we use this for any perimeter problem question. So step 1, we calculate the perimeter if it's not given. Now here it is. So we're going to say 14 metres. Then we calculate the next step of how much we need of an object, for example, how many fence panels, how many hedging strips, how much ribbon, by doing the perimeter, which is 14 metres, divided by the width of the object, which here is 2 metres. So 14 divided by 2, how many of the object we need? We need 7 fence panels. Now, if this was 7.8 or 9.2, you would round it up, because obviously we can't go and get 7.2 fence panels or 9.3, so you would round it up. And then finally, to do the cost, we do our object, which is 7 fence panels multiplied by £12, and our total cost is £84. Fantastic. Right, let's now have a go at this using a simple question. So Jenny wants to fence her garden. Using the information on the left, calculate the cost of fencing Jenny's garden. And we may use a calculator. So firstly, we need to calculate the perimeter. Now with this question, it isn't given, so we're going to have to work it out. So we know we're going to add all our sides, 3.5, add 5, add 3, add 6. The reason why we're not doing these sides is because she's not fencing that. That's her living room. There's a wall there, whereas she only fencing these parts of her garden. So literally, we add all those together and we get 17.5 metres. Then, to work out how much we need of our fence panels, we're going to do our perimeter, which is 17.5, divided by the width of our object, which is, as we can see here, 1.83. And that leaves us with 9.56 fence panels. And as before, we cannot buy 9.56, so we're going to have 10 fence panels. And then lastly, we do our object multiplied by our cost. So we know we need 10 fence panels, multiplied by £24 they are each, and our total is £240. And that is how we calculate perimeter and how we do problem questions associated with perimeter. So one of the alternative shapes that you might be asked to deal with perimeter is circles. So before we deal with anything to do with circles, we've got to understand what the parts of a circle are, because each part of a circle is used for different parts of questions. So for example, radius and diameter, separate parts of a circle, parts is used for perimeter, some is used for area. So from the center point to the end of the circle, this is known as the radius. From one side of the circle to the other is known as the diameter. So sometimes we need to work out the other when only one is shown. So if we wanted the diameter, we double our radius or times it by 2. If we wanted our radius, we do diameter divided by 2, or half the radius, half the diameter, sorry. So what would the diameter be if the radius was 5? So we know to do diameter, we need to do the radius times 2. So here, our radius is 5, we're going to times it by 2, so our diameter is 10 centimetres. Okay, what would the radius be if the diameter was 20? So we know to work out radius, we're going to do diameter divided by 2. So radius is going to be 20 divided by 2, which then means our radius is 10 centimetres again. So now we know the different parts of a circle, we can use this to understand how to calculate the perimeter. Like other shapes, you can calculate the perimeter of a circle. However, we change the terminology and call it circumference. They are the same. So perimeter and circumference of a circle is the same. And this is the formula to calculate circumference. Now this little symbol here is known as pi. And pi is always equal to 3.14. Sometimes it may be given to you in a question. If not, use 3.14. So this little formula here actually means pi times the diameter. Oh, sorry, my pen's just broken a little bit. Better, do apologise about that. So yes, pi multiplied by the diameter. So in this circle, we have the radius. So to get the diameter, as we know, we do radius times 2. So we're going to do 7 times 2, which is 14. And now all we need to do to work out the circumference is do pi times the diameter, which equals 43.9 inches. Now, sometimes we might be given different circles in order to calculate circumference. So all we've got to remember is our formula pi times diameter. Okay, let's have a look at our 3 circles. So our first one is a semicircle. So if we were asked to calculate the perimeter of this semicircle, what we need to do is we need to do pi times diameter. And then, because it's a semicircle, divide by 2. So we're going to do 3.14. Our diameter is 10. Divide it by 2, which gives us 15. Centimeters. Then our next one, we have a quarter circle. So to work out our circumference of our quarter circle, we're going to do pi times diameter, but this time we're going to divide by 4. So we're going to do 3.14. Now our diameter, if we imagined this was a full circle, going to be another 6 there. So our diameter is actually 12 divided by 4. So 3.14 times by 12 divided by 4 is actually 9.42 centimetres. And then our last one, how many quarter circles are in this one? It's 3, so it's what we call 3/4 of a circle. And what we do here is we do pi times diameter, divide it by 4, and then multiply by 3. So 3.14, notice all the way across will be 10, divided by 4, and then times by 3. So then we've got 31.4 divided by 4 times by 3. 31.4 times by 4, 31.4 divided by 4 is 7.85, divided by, times by 3 is then 23.55 centimetres. Now, what's really important to establish is that when you are working this out, you're actually only ever doing the outside. Is this part here. This part and this part. So actually, if you wanted this part, this part, and this part, and this part, and this part as well, you would need to add those lengths in after you'd calculated the circumference. So for example, if you wanted to know what all the way around was, you would have to work out this semicircle part first and then add in 10. If you wanted to work out these bits as well, if someone was fencing these bits, you would work out the quarter circle first, then add 6 and 6. You would, if you wanted all the way across, you would do so you do your 3/4 and then add those bits in addition. So it would be 23.55, add 10. It would be 9.42, add 12, and then it'd be 15.7, add 10 to get those extra parts as well. Okay, now we've finished with perimeter, we're now moving on to area. Now, area is the amount of space inside a 2D shape, and we calculate this, and it's always measured in squared units. So it's centimetres squared, metres squared, inches squared, feet squared. And we always calculate this by multiplying the length times the width, and this is only applicable to rectangles and squares. So here we would do 6 multiplied by 3. Remember, our units are squared, so it'd be 18 metres squared. Okay, now, just before we start looking at problem questions, let's have a look at calculating the area of these 4 shapes. So we're going to do 8 times 3, which is 24, so 24 squared centimetres or centimetres squared. We're then going to do 5 times 7, 35 squared feet or feet squared. Then we've got a rectangle, a square, so we're going to do 3 times 3, which is 9 squared meters, and then our last one, 10 times 4, which is 40 squared inches. And that is how we calculate area. So now we can do that, we can look at things like compound rectangles. So this is, as before, combination of rectangles. Whenever you are calculating compound rectangles, you must split the shape into several pieces. So we're going to split it here, and we're going to split it into 2 different shapes. We're going to call this shape A, and we're going to call this shape B. And we're going to work out the area of each. So let's say area of A, and area of B, and then we're going to add together. So here We're not going to do 5 times 4 because that would be what it was cut off here. We need to know what this length is. So as before, we're going to look at the opposite side. All the way down, we know is 4 and 2. So this missing length must be 6. Now we can work out the length and the width, so we can work out the area. So 6 times 5 is 30 centimetres squared. And then the area of B is 4 times 2, which is 8 centimetres squared. We then add them together and we get our area, so 38 centimetres squared. Okay, now if we were looking at problem questions, say when we have problem questions, we have things like carpeting, tiling, painting, because it's inside a shape. So for example, James needs to carpet his living room, which is 40 metres squared. Each carpet tile has an area of 0.5 metres squared and costs £6. How much will it cost to carpet his entire living room? So we calculate the cost by calculating the area first. Now this one, it's given to us, so we're going to say 14 metres squared. Then we calculate the area of the shape of the room, which we know is 14 metres squared, and we divide that by the area of the object, so whether that's paint or tile, what can be covered, which is 0.5. So we do 14 divided by 0.5, and that tells us how much of the object we need, which is then 28 tiles. And then to find out our last bit is to multiply by our cost. So then we're going to do 28 multiplied by £6, and that gives us a total of £168. And there are 3 steps again to working out area problem questions. So now let's have a go at some. So James needs to paint his living room wall. The wall is 5 by 2 metres and each tin of paint covers 1 metre squared and costs £10.99. What is the total cost to paint the room? So we're going to calculate the area where we're going to use these 2 measurements. So 5 times 2, and his room is 10 metres squared. Okay, step 1 done. We then do the area of the shape or room, which we've just calculated as 10 metres squared, divided by the area of our object, which we know is 1.5. So let's have a look. How many tins of paint does he need? 10 divided by 1.5, and he needs 6.67 tins. Now we know we can't buy 6.67 tins, so we're going to round to 7. Then he'll have some left over. And then we're going to multiply the cost, so 7 multiplied by £10.99, and that brings us to £76.93. And there is our problem question done. Okay, let's try another one. Sally wants to know how many chickens she can keep in her field. Her field is shown below. Her field is 4 metres long and 5 metres wide, and each chicken needs 0.5 metres squared of space. How many chickens can Sally keep in her field? Now this time we don't have anything to do with cost, so all we need to do here is just do the first 2 steps. So 1, we're going to calculate the area. So what is the area of the field? We know it's 4 multiplied by 5, which is 20 metres squared. We then do our area of our shape divided by the area of the object. So here we know our field is 20 metres squared, and we know that each chicken needs 0.5 metres of space. So 20 divided by 5 tells us that Sally can keep 40 chickens. Okay, brilliant. Right, we're now going to move on to another shape now, which is the area of triangles. Now, the area of triangles have their own formula as well. So here we do half of the base times height, or base times height divided by 2. It's entirely up to you how you want to do it. I find it easier to do base times height and then divide by 2. So the base is the bottom of the triangle, which here is 8 centimetres. The height is from the bottom of the triangle to the top, not this. This is not the height, that's the side. So this is our height. Which is 8 times 6 and then divided by 2. 8 multiplied by 6 is 48. Divided by 2 is then 24 centimetres squared. Okay, so just spend a couple of minutes now having a go at this one. So can you solve the area of this triangle? Okay, so we've got our base times our height divided by 2. So our base is 5 multiplied by our height, which is 45, and then 45 divided by 2 is 22.5 centimetres squared. Fantastic, brilliant. Okay, so next we're going to look at compound shapes. So we've touched upon this slightly with combined rectangles and things like that. So what is a compound shape? So a compound shape is a shape made up of multiple shapes such as rectangles, triangles, and even circles. When calculating the area of compound shapes, you may need to follow two methods. Method 1, where we add the shapes together. So here we have a rectangle and a triangle, and we want to know the area of the shape. So first we've got to do the area of the rectangle. So we're going to do 8 multiplied by 2.5, which is 20 metres squared. And then now we've got our triangle. But what makes our triangle slightly tricky is we've got no base. But we know all the way across from here to here is 8 metres. And we know from here to here is 2 and here to here is 2. So we've got 4 metres. So that must mean that this one is then 4 metres. So we've now got our base. So we're going to do 4 times 3, which is our height. So that's our height. And that's our base. Then divide that answer by 2, so 12 divided by 2 is 6 metres, and then our total is then going to be 20 add 6, which is 26 metres squared. And that is our first way of calculating compound shapes. Our second way, which you might have to deal with your exam, is you've got one shape that's missing a piece out of it. And that piece that's missing could be a circle, it could be a triangle, it could be another rectangle, it could be a square. And you have to just work out the area of one part of the shape. So here we want to work out the part of the yellow shape. So what the best thing to do first is to join your edges up so you find out your missing piece. And your missing piece is a rectangle. Now we want to know what the measurements are for that missing piece. So we know from all the way across is 10, but from 9 here to here is 9, so that must be 1. And then from here to here is 5, but here to here is 3, so that must be 2. And then what we're going to do, we're going to do the area of the yellow, take away the area of the missing piece. Because we actually don't need that missing piece, we only need this bit. But if we calculate just the yellow bit, you're including that within it. So the area of the yellow would be 5 times 10, which would be 50 metres. The area of the missing piece would be 1 times 2, which would be 2 metres. So we're going to do 50, take away 2, which then leaves us with 48 metres squared. And that is compound shapes. So let's have a go at one of those. The corner of this rectangle has been cut off. What is the area of the shape now? So we're just dealing with the green shape. What do we think we have to do? So we are going to calculate the area of the green part. So the big rectangle, take away the area of the missing corner, which is a triangle. So it's always good to deal with what shapes you're dealing with. So to green part, which is the big rectangle, we're going to do 9 times 13, which is 117 centimetres squared. And then the area of the triangle we know is base times height divided by 2. So it's 4 times 4 divided by 2, which is then 8 centimetres. 117 take away 8 is then 109 centimetres squared. And we've got our answer. Okay, our last shape that we are going to deal with, we're going back to circles again, where now our formula changes when it comes to area. So the area of the circle is calculated using the formula pi r squared, which means pi times radius times radius. And what I would like you to get in the habit of is whenever you've got a question dealing with anything to do with circles, you are writing the formula out in full. So for example, this is how I would like you to structure your response to a question. So if we wanted to calculate the area of this circle, we're going to do pi times radius times radius. We're going to write that out first. Underneath our pi, we're going to put 3.14 because that's what's given in the question. And our radius is then 5 times 5. So 3.14 times 5 times 5 is 78.5 centimetres squared. Okay, now let's deal with the second circle. So we're going to write out our formula again. But this time, we can have a look at this circle. And this 1.5 is the diameter. So to get the radius, we know we've got to do diameter divided by 2. So we're going to do 1.5 divided by 2, which gives us 0.75. So now we can add in our numbers, 3.14 times 0.75 times 0.75, which then gives us 3.14 times 0.75 times 0.75, area of 1.77 meters squared. Right, let's have a go at a problem question now. Chris has a fish pond. This is shown in the diagram below. Chris wants to know how many fish he can keep in his pond. Each fish needs 0.25 meters of space. Calculate how many fish Chris can keep in his pond. Okay, so we know we're dealing with a circle. So we're going to do area, which is pi times radius times radius. Okay, we know that our pi is 3.14 and our radius is 4. So firstly, we've worked out the radius, and now we're going to work out the full area using our formula times 4 times 4, and our area is 50.24 meters squared. Then to work out how many fish, we're then going to do our area like we've done before, divided by the area of the object. So 50.24 divided by 0.25 then tells us how many fish, which is 200.96. It's not enough room for 200. Not per small fish. So we round to 201. Sorry, it's not enough room for 201, even though that's 296. So we round down to 200. Sorry, if that ever comes up and it's something like 200.32, doesn't matter. Rounding will slightly go out of the water, literally with a fish question, or anything with inside, because it's over that amount. So you're always going to round down to the number before. So it's not enough room for 201. We round down to 200. Okay, let's try our last question today, which is a problem question that puts together everything that we've learned today, specifically with area. So Omar wants to paint his house. His house is shown below. He wants to paint the outside, but not the doors and the windows. Both windows are the same and have a diameter of 1.2 meters. Each pot of paint covers 3 meters squared and costs £14.99. His budget is £50. Will he stay within budget to paint his house? Okay, the first thing to establish is what type of question it is. So he wants to paint a wall. Okay, so because he's painting inside, because it's inside, it equals the area. But we know he doesn't want to paint the doors and the windows. So what we are going to have to do is we're going to have to do the area of the wall, take away then the area of the door, and then take away the area of the windows. So now we've established this, we can then work through each part. So the area of the wall is then 8 times 3.5, which is 28 meters squared. The area of the door is 0.3 times 0.2, which is 0.06. And everything seems quite simplistic so far. However, we're now dealing with the windows, which are circles. So we're going to have to remember our formula of pi times radius times radius. So 3.14. Do we have a radius in our question? No. So the diameter is 1.2. So the radius is 1.2 divided by 2, which is 0.6. So times 0.6 times 0.6 gives us 1.13 meters squared, and that is for one window. So now we're going to have to double that to get the two windows. So 1.13 times 2 is 2 windows. So that gives the area 2.26 meters squared. Now we're going to do what we said we were going to do at the start. So we're going to do, so to work out the total area to paint, we're going to do 28, take away 0.06, take away 2.26, which gives us a total area to paint of 25.68 meters squared. Okay, now we need to work out how many tins of paint. We know one tin covers 3 meters squared, so we need to go back to our area problem question method. So here, to work out how many tins of paint, we do the area of the object divided by the area that it can cover. So here, 25.68 divided by the area of the object that you're looking at, which is 3 meters squared, about how many paint. So 25.68 divided by 3 is 8.56 tins, which we know we can't get. So we need 9 tins of paint. And then to work out the cost, we know each tin is $14.99 and we need 9 of them. So 9 times $14.99 then leaves us with £134.91. His budget's £50. Will Omar stay in budget? No, and it's always good to use figures. He is over budget by £84.91. And that is how we solve combination area problem questions. So it's about breaking it down into the shapes that you know and solving each part. So there is nothing in that question that we haven't covered. We've covered areas of rectangles, areas of circles. We've covered how to solve problem questions. And it's literally then a case of multiplication and division. I'm just highlighting all these bits so that you know where your steps are. And I'm just going to highlight the last little phrase so it knows we know we've answered the question. No, he's over budget by £84.91. And that is our session intent completed. So we've understood how to calculate perimeter in 2D shapes, including combination of rectangles, understanding how to calculate perimeter and circumference in circles, understanding how to calculate area in 2D shapes, including a combination of rectangles, and how to calculate area of triangles and area of circles. So thank you today. So there is, I have attached to the session some revision cards on shape formulas to remember and a worksheet to complete on some problem questions. So thank you very much.